Okay, so we are on Wednesday, March 18th. We'll pick up where we left off. I guess the bonus of this is that you can go back when you need to. We are in 0.3 with radicals. I will utilize one of the other textbooks. This is one of the sections that we have to supplement. 0.3 is very limiting. They assume a lot. So I'm using the 090 textbook where 0.3 covers like 7.1 through 7.7 or something like that, where it's several sections. So as we go through, I'll be drawing from examples for that. We know that we're dealing with radicals. They'll have this symbol in it. Some basic definitions. We'll do a bunch of square things with square roots. We'll do a bunch of things with cube roots. But then we have to go through and where we have to have the ability for other roots. We call those nth roots, where it's a 4, a 5, a 26, a 42. But we want to build on basically square roots and cube roots. This is a building block of a lot of what we'll do is going to be square roots and cube roots. Okay, so a square root. A square root, what we want to think of is one of two equal parts. The basic definition, one of two equal parts. We're looking for the same number that is multiply together, or the same value, meaning it could be, we don't know what that number is, so x squared would be x times x. That's the same one of two equal parts. So when we think of our definition, every time we think of this, when we go square roots, cube roots, nth roots, we're thinking of one of so many equal parts. This is really what the index will tell us. Remember, if it's not written there, we understand it to be a 2. So a square root is one of two equal parts. Well, cube root has a 3 there. So a cube root we think of as one of three equal parts. The same value times itself 3 times. Okay. A fourth root, we change that to a 4, would be thinking of one of 4 equal parts. So things I need you to think on is, what are perfect squares? What are perfect cubes? If you can generate a list, usually I say the top 12, 13 numerical perfect squares. So 1, 4, 9, 16, 25, 36, etc., etc., etc. Or the first 5 or 6 perfect cubes. 1, 8, 27, 64, 125, 216. It will help with recognition down the line in terms of problems in the book. Those are the most popular. Beyond that, it comes down to going to the calculator. This item times this item times this item. What is that perfect cube? And then using the technology. Okay, I'm going to erase this and go through some problems so we can have this one clip. I'll clean it up later. Okay, so let's do some evaluating. Thinking of evaluating these, always approach it as if you don't have your calculator. How can we approach it without the calculator? Okay, so if I have the square root of this, we're looking for one of two equal parts. Okay, we're looking for one of two equal parts. Now I'm going to rewrite this in a specific manner. We know that 36 is 6 squared, 6 times 6. The reason I rewrite, if I practice on the items that I know what they are, it will help us down the line in terms of rewriting some information. We know that in this manner, that when you have a base raised to this power, this base is represented that many times. So this 6 is the one of two equal parts. So the square root of 36, or the square root of 6 squared, is 6. So if I have something along the lines of square root of 81 over 64. Now I could look at this and just plug it in the calculator and let it do the work. Imagine you don't have your calculator. When you see a fraction, know that the item, unless you can reduce this further, the item that you should come out with, we want to be an exact value. Okay, so if it has a fraction here, I know that I'm going to have a fraction here. Now yes, the calculator will spit out the decimal value. For us, we will have calculator problems, but the instructions would say evaluate to so many decimal places, and really what you're working with is the rounding. So when we look at this, I can think of this as basically a square root of the numerator, square root of the denominator. We'll get to more things like that. But when I look at it, I can look at it as the square root of, I know 81 is 9 squared. I can think of it as the square root of 64. I know that's 8 squared. Well, the base is the item that is the one of so many items we're looking for. So it's one of two parts here. So one of two parts is going to be 9. The one of two parts here is going to be 8. Okay? So the square root of 81 over 64 is equivalent to 9/8. Now, if you just plug that in a calculator, yes, you get a decimal value. If you round it, depending on if that's terminating or non-terminating, you could be further away. What about this? Negative square root of 100. When you go through and evaluate this, what I need you to think of is think of your order of operations. Please excuse my dear Aunt Sally. When you go through and evaluate, think of this radical, think of it as a parenthesis. Later on, we'll think of it potentially as an exponent, but not that something that you distribute into type parenthesis, but in that we want to evaluate it here. We want to evaluate this first. We want to evaluate this value and then do this. What this really represents, this is really -1 times the square root of 100. So if I evaluate this, hopefully some of you are saying, well, I know square root of 100, it's 10 times 10. So I have 10 for that value. But I still have that -1 out in front. So negative square root of 100 is equivalent to -10. Okay? Now, we're going to go through and we're going to do a bunch of these. And remember, as we proceed, we're going to have the you try problems. You try them out. After you upload them at the end of your viewing, you will then have the solutions to those open up, and you will be responsible for those for notes. Okay, so we'll pick up in the next clip with doing some more evaluation. Make sure you have your calculator handy for this.